Hello everyone, welcome to ET240 Statics. We're going to be going through chapters 1 through 3. Most of this is a lot of trigonometry. We did some review in your module 1. So real quick, think to yourself, what's the difference between a vector and a scalar? So a scalar has what? A scalar has magnitude. And an example of this may be time, and that's seconds, or maybe temperature. Yeah, it's getting warm in Las Cruces again, so that's kind of nice. That might be degrees Fahrenheit. So what makes that difference from a vector? Well, a vector has not only magnitude, but it also has direction. So we may say this force is acting at 50 newtons, that's our magnitude, at an angle of 30 degrees from the positive x-axis. So then now we have direction. So when we're adding two vectors, let's say we have, I'll use my kids' names, Leah and Isabella, and sometimes they like to fight, right? So let's say they're pulling a wagon out in the backyard, and one's pulling at 15 pounds of force, and the other one's pulling at, the little one is pulling at 20 pounds of force because she's kind of crazy. And let's say that if we put our axis in here, my older daughter's pulling at a 30-degree angle from my x-axis, but my younger daughter's pulling like at a 60-degree angle because she's mad, she doesn't want to be near her sister, so she's yanking it this way. Well, we could look at this and say, alright, well, which way is this wagon actually going to move? Well, just by looking at things, my force resultant is going to be somewhere in here, right? And how do we solve for that? Well, we can use law of cosines. We can use breaking these up into its own components and then adding them, and then taking the looking at Pythagorean theorem to solve for that. So we're going to be looking at that both ways. So let's go ahead and jump into an example. So I have an example here. I have a 6 kilonewton force acting 60 degrees from the negative x-axis. Sorry about that. Okay, so this is my negative x-axis, and this is my y. So this would be my negative x, and this would be my x over here. This would be my negative y. And we could also say that this is 30 degrees. And we could also say here that this would be 45 degrees, however you want to put it. So I want to add these two vectors to find my force resultant. And the first way I'm going to solve for this is I'm going to solve for it using the law of cosines. So if I'm going to use the law of cosines, I can do it in a few different ways. One way would be to move this vector and put it over here. So I'll go ahead and draw that in as close as I can. There. So I've just moved it over here. Then I could draw from here to here. This is head to tail. So I drew this from the head to the tail of the vector. And this green line depicts my force resultant. So let's see how we can solve for this using the law of cosines. So just a little bit more information I'm going to need. What's this angle here? Well, this angle here is going to be 60 degrees here, and it's going to be 45 degrees here. This is 45. Since this is 45 and we moved it, we can say this stays 45 degrees. This would be a 30, 60, 90 triangle. So 30, 60, and then if we came down, that would be our 90. So we know that the law of cosines, I'm just going to put law of cosines, is c squared is equal to a squared plus b squared minus 2ab times the cosine of c. Now, we are trying to find the force resultant, so we're going to call this side here, this green side, we're going to call that c. So I'm going to go ahead and put that in as fr. Then I'm going to say that a squared is my 6 kilonewton side. So this actually, I'll write it over here so it helps us a little bit. 6 kilonewtons. And then over here, this is going to be our, let's try that again, 2 kilonewton side on this side right here. So I can say, okay, A squared then is going to be 60 kilonewtons squared plus 2 kilonewtons squared minus 2 times 6 kilonewtons times 2 kilonewtons times the cosine of the angle. And what's that angle going to be? Well, that angle is this angle right here. Mark that in green here. That entire angle. So that's going to be 60 plus 45, which is going to be 105 degrees. Now, since I don't have it squared over here, I can just say, okay, I'm going to take the square root of all of this, and that's going to be my force resultant. So my force resultant then is just plugging this into my calculator, and I come up with 6.8 kilonewtons. And then on my homework or my quiz, I will highlight it, or I would box it in so I can see the answer. Then I could use the law of sines to find the angle. And in the book, it's asking us to find it from the positive x-axis. So we're going to need to find this angle here. So using the law of cosines, I can find, first, I could find this, let's use green. I could find, green. I could use this angle here, and then I know this is 60, and then I can subtract 60 plus whatever angle I find to get this small angle, and then I could add it to 90 to get the direction from the positive x-axis. So what I'm solving for first is this angle right here, right in here, and we're going to call that alpha. So I could say the sine of alpha, and what's opposite of alpha? It's my 2 kilonewtons, is equal to, let's go ahead and use sine of 45. So we also know that this angle here is 45 degrees. Okay, so we know that this is 105 degrees, and we know our force resultant is 6.8 kilonewtons. So I can come in and say that the sine of 105 degrees over 6.8. So cross multiplying those two, I can come in and say, all right, I'm going to have sine alpha times 6.8 is equal to 2 kilonewtons times the sine of 105 degrees. So really I'm just dividing by 6.8, dividing by 6.8. Now if I look at this, I can say alpha is equal to the sine or arc sine of 2 kilonewtons times the sine of 105 degrees all over 68. 6.8 kilonewtons. 6.8. So plugging this into my calculator, I get that alpha is 16.5 degrees. So again, that's this piece here. So now I can say 90 degrees minus 60 degrees minus 16.5 degrees is equal to 13.5 degrees. Now this is going to be from the, this would be clockwise from the negative y-axis. But, go back to the drawing, we wanted this purple angle, or from the positive x, so we know this little angle in here is 13.5. We add that to 90, so we can call it theta is equal to 105 degrees, 103.5 clockwise from the positive x axis. Now, if you were just asked for a numerical answer here, and it said from the positive x-axis, the actual would be negative 103.5 degrees. Meaning that on a quiz, I may ask you to solve for this angle from the positive x, and if it was down here, you would say it's negative 103, because if I'm going clockwise, that would be negative. If I'm going counterclockwise, that would be positive. Okay, let's go ahead and solve this problem. I'm going to move this like this. Okay, so we have our problem up here again. Now I've got 2 kilonewtons and the 6 kilonewtons. So I can come in and say, all right, I'm going to call this one F1 and I'm going to call this one F2, just to kind of help me organize my work here. So I can come in, let's use yellow here, F1 and F2. So my x component for F1 would be, remember I'm breaking this up, so this is going to be going in this direction, and then my y component would be here for F1, and then for F2 my y component there, and then my x component there. So you can notice that for F1 I'm going to have a negative x component and a negative y component, and for F2 I'm going to have a positive x and I'm going to have a negative y. So for F1 x, that's this red one right here, I'm going to say that's going to be 6 kilonewtons times, now that's going to be adjacent, so that's going to be cosine of 60 degrees. My y component then would be 6 kilonewtons times the sine of 60 degrees. And what we get there is this would be actually be negative, and this is actually going to be negative. So this here would be a negative 3 kilonewtons. And this here would be a negative 5.19 kilonewtons. Now for F2, my x is going to be positive, and that's going to be 2 kilonewtons times cosine of 45 degrees is equal to, when I do this, I get 1.41 kilonewtons, and then my y component is also negative 2 kilonewtons times the sine of 45 degrees. And when I calculate that out, I get negative 1.41 kilonewtons. So then what I'm going to do is I'm going to go ahead and solve and sum my x components and my y components. So my x components would be a negative 3 kilonewtons plus a 1.41 kilonewtons, which there I'm going to get a total of 1.59 kilonewtons, and that's going to be negative. And then summing my y, here I'm summing them, my y component here would be a negative 5.19 kilonewtons minus 1.41 kilonewtons. Add those together, I'm going to get 6.61 kilonewtons. So that would also be negative. So coming back to my figure here, if I drew these two my components, these are my new components from my force resultant, I can actually draw them back up here. So I can say, okay, my x, I'm going to go negative 1.519, so I'm going to be about there. And then 6.61, I'm going to go down, so I'm going to be somewhere down here. And I'm going to draw my force resultant. Kind of look familiar? Oops. Kind of look familiar from the way we did it on the law of cosines. So and I can just draw my triangle and say this distance was 1.59 and this distance was 6.61. Now we don't really need to worry about the positive negative at this point in time. So how do I solve for a hypotenuse given that this is a right triangle, 6.61, 1.59? We use the Pythagorean theorem. So my force resultant, which is my line here, is going to equal 6.61 squared plus 1.59 squared. Now you may say, oh, what about the negatives? So then I can just say
Well, this is also the same as 6.61 negative, right? Squared plus 1.59 negative squared. And you're going to get the same thing. So when you plug this in, you get exactly well, not exactly, but I rounded to 6.8 kilonewtons. Same thing as we did when we did the law of cosines. Now, the same thing as we did the law of sines, I can solve for this angle right here. And I could say that the tangent, and we'll call that theta. The tangent of theta then is equal to the opposite over the adjacent. So theta then is going to be equal to the arctangent of those two. So plugging that into my calculator. Remember, you have to be in degrees. If you're in radians, you're going to get something different. So make sure you calculate this out on your calculator to get the same answer. I got 13.5 degrees. Now, again, this is from the negative y-axis, and this would be clockwise. But since the question asked me to solve it from the positive x-axis, I'm going to say 90. So if we said, again, this purple line here, this angle here, we'll call it phi. That would be 90 plus 13.5, which is going to be 103.5 degrees. I hope this helps. If you have questions, please post them in the discussion, and then we'll go from there. All right, have a good day.